Okay, it's 8:40. I think anyone's watching yet. Just going to switch. There we go. That looks about correct. Well, how's it going, everyone? Today I'm going to be spending another 2 hours on my calculus homework, and in today's video, we are going to be seeing combination of rules for differentiation. Now it's the morning, so I gotta focus. I'm not gonna be talking a lot. You guys are just gonna watch me do my calculus homework. That's it. Just watch me write, enter. I'll share my screen. However, for copyright reasons, I'll probably not share my screen when I'm watching a video or something. But I hope you enjoy. I don't exactly know who's watching me. Yeah, type something in the comments, and I'll try to respond. I might not see the comment immediately, but it's okay. Yeah, I don't even know if anyone's watching, so it's fine. Well, let's do this. So I got to begin with a lecture. Yes, I got to watch a 30-minute video. Yeah, here I share my screen. Let me just share the screen. There we go. Yeah, so I got to watch this 30-minute lecture, and then I will do my homework. I'm not sure how many questions there are. I'll probably see after I finish my lecture. Yeah, all right. So I guess I will begin. Hold on. I'm just gonna stop sharing my screen. You guys are just gonna watch me watch the video. So here we go. Here we go. I hope you all have fun watching me watch the video. Yeah, let's do this. Oh, and one more thing. I mean, I can hear the video. I don't know if you guys can hear the video. If you guys don't hear the video, then I don't know. I mean, I guess you'll just have to watch me then. Here we go. All right, we're 2 minutes in. Let's do this. Okay, how about X? Okay, I see. E inner 4x sine of y. Yes. Okay. Yeah, compositions. So we got g prime of x. So we have g prime of x. So hold on. We have f of g of x. One, two, this. This thing is gonna fall on me any second. However, okay. So we have f of g of x, sine of 4x. Um, so we'll have something like, hmm, we'll have, yeah, so the derivative of 4 is, no, I'm sorry, the derivative of 4x. Yeah, the inner function is 4x. Yeah, my bad. So we have 4 times f prime of g of x, and that's going to be cosine of 4x. 4 cosine of 4x. 4 cosine of 4x, is that right? We're so good at this. Let's go. Hold on, let's hear that. Mhm. Yes, sir. I'm sorry, what? Oh, yes. So the product rule, f of x times g prime of x plus f prime of x times g of x. So we will have x to the power of 3 times the derivative of x to the power of 3 sine of 4x, and we get 4 times cosine of 4x, plus the derivative of f of x, or the derivative of x to the power of 3, and we have 3x squared times x to the power of 3 sine of 4x. I believe that's correct. I'm just going to skip it a little bit. Yes, let's go. 4x plus 3x squared sine of 4x. Uh-huh. Yes. Mm-hmm. Mm-hmm. Gotcha. All right, we have multiplication, yeah, sine squared of 2x, and 4x plus 3 to the power of 9. We have a combination of functions. I believe we have sine of x. No. We got, uh, yep, and that's a lot of combinations, right? We got 2, we got sine of x, and we got z squared, I think, something like that. Mm-hmm. Yes. Okay. No, that's wrong. Why did you put 2x? Oh, hold on. So we have the input, we got the function, and then we got it squared. Okay. Yeah, so I'm guessing we got 2x sine of y and then z squared. Yeah. Yes, sir. Mhm, mhm. Nice. Alright, so you apply the chain rule and to both terms, and then you apply the power rule. Gotcha. So to differentiate the 2 terms, and then the product rule, both of them. Mhm. Hold on, wait, let's look at this. Okay, so to differentiate the 2 terms, right, as their raw versions, and then the product rule to differentiate the 2 functions. Yeah, okay, yeah. Well, yeah, so the innermost is 2x, the inner is sine of y, and then the outer is z squared. Yeah, so 2, yep, mhm, it's cosine of y, yes, and then we got 2 z. Yes, sir. So, alright, let's see, so that's gonna be what's it gonna be, guys? Um, let's see. Alright, I guess we can join 2 2 of these compositions in order to form 1. So, okay, let's do, you know, how do you do this? Sorry, what are you doing? Okay. What? Oh, hold on, yeah, so that's the original function. Oh, no, no, no. I see, I see. G prime of x times, but we didn't apply the derivative there. What's going on? Oh, that's the derivative. My bad. So we get, yeah, g prime 2 times the derivative of sine of y evaluated at 2x, and that's going to be cosine of 2x, times that's an entire one. We can treat that as an entire function, and then um, we do. Oh, no, 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 no. I'm sorry. So if we treat this as g prime of x, so don't we have to differentiate that? Hold on. Oh, okay, no, I gotta see this. 2 sine. How did we get to 2 sine? So 2 is g prime of x. Why do we have sine of 2x though? So, all right, hold on. So, yep, that's common. composition, not combination. So we have the inner is going to be 4x plus 3, and the outer is going to be y to the power of 9. So we have the derivative of 4x plus 3 to the power of 9 is going to equal 4 times 4 times 9, 4x plus 3 to the power of 8. Hmm. Hmm. Yes, sounds good. So here we get ooh, that's gonna be a long one. All right, well, yeah, the derivative of the multiplication of those is gonna be that times the derivative of that times the derivative of that. Oops, no, plus the derivative of that times that. Yeah, so, oh, what do we do now? Oh no, no, well, we're good. That's the original function. Yeah. Derivative. It Okay. Okay. Yeah, the derivative. The derivative of c in respect to t. Okay. Seven. Negative sin of y. Mm-hmm. Oh, it's gonna be mm, it's gonna be 7 times negative sine of 7. Mhm. It's gonna be yeah, so 5 times 5x to the power 4 or 25x to the power 4. Ah, nice. Elodie high, Heidi low. So we get mm, 5x raised to the fifth times mm, times negative 7 sine of 7x plus, yeah, g of x. No, 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 no. Wait, no. Okay, no. Let's do it the other way. Let's do f prime of x times g of x minus f of x times g prime of x. I like that. So let's do negative sine of 7x times 5x to the power 5 minus, then we do, what is it? Cosine of 7x times the derivative of the lower. So 25x to the power 4. All of that over, what is it? 25. What's that raised to the power of 2? Yeah, 25, right? 25x times 25 times x to the power of 10. I believe we got that right. Yeah. Uh-huh. 25x to the power of 10. Mm-hmm. Well, but this is a long video. We still got 17 minutes left. Gotcha. Okay, let's keep going. Okay, so we got composition with our square root. Yeah, we got two compositions, and then we got the quotient. So we have to use the chain rule to differentiate square root of 5t squared minus 7t and cosine of 8 minus t to the power 4. And then we must use the quotient rule to differentiate, well, yeah, the entire fraction. Mm-hmm. To the power of 1 half. Yeah, phew, okay. Yeah, we're using chain rule. Yeah. Mm-hmm. Mm-hmm. It's gonna be, what's it gonna be? It's gonna be 1 half y to the power of negative 1 half times, ooh, um, oh wait, hold on. No. No, no, no. My bad. It's gonna be 10t minus 7 times 1 half 5t squared minus 7t to the power of negative 1 half. Mm-hmm. Yes. Mm-hmm. We, uh, yeah. Uh-huh. All right. So we get, yeah, derivative of cosine of 8 minus t to the power 4 is going to equal negative 4t cubed times negative sine of 8 minus t to the power 4. Yes, I'm hungry. Uh-huh. Awesome. All right. That's 10 minutes left in the video. Gotcha. How's it going? Oh, there's one person in here. Oh, let's go. Thought I was alone in here. Okay. Well, how's it going? Is it going good? Okay. Um, right. Oh, there's two people. Whoa, what happened? Oh, how's it going, guys? Is, is it going good? We having a good day so far? What are we gonna go do today? Are we like on spring break? Okay, that's awesome. Okay, all right. Well, let's do it. So we have what do we got? So we got g of x equals. Okay, hold on. In fact, let me just put it. G of x equals 6x. Um. Oh, whoops. There we go. Cool. So, mm, awesome. So I'm guessing that we will use a chain rule for cosine of 6x and sine of um and sine of x, I think. Mm, oh, and yeah, and we also um the entire fraction squared. Okay. How about sine? No? We're not gonna do sine. Probably not. Okay. Mm-hmm. Wait, why? Okay. All right. Let, let's do this. Or in fact, no, no, no. I'm not gonna do this right now. I'll just save up my energy for the homework, and um I'll just watch the guy do it. Okay, so there you go. Hmm. why don't we just evaluate? Mm, right. Okay. Mhm. A white word, right? Yeah. Mhm. Yeah. Mhm. That's squared. Squared, right? Wait, whoa, why? Hold on. So we're using the chain rule, derivative of the inner, that's what we did, and then we did derivative of the outer evaluated at the inner. Evaluated at the original. Oh, yeah, and the original is 5x cosine of 6x. Oh, oh, 2 times, right, mhm. I right, you don't have any squared. Oh, we got it to the product? Okay. Okay, I think I understand. Okay. We did the product right there. Awesome. Alright, now okay, it's time to begin our homework. Oh, come on, just click the wrong thing. Here. In fact, I will share the screen. Oh, cool. Here, let me open the homework. And what's up over here? What grade are you? I am in 10th grade. Um, however, I'm a student at ASU. I'm still in a high school. Yeah, I'm taking these classes as a 10th grader. And where am I from? Um, where am I from? I am from the US. I don't know if it would be wise to give more specifics, but yeah, thanks for being here, guys. Okay, let's see. Hold on. Perfect. Looks like we can begin. Combination of rules for differentiation. Start homework. Here we go. Oh, we only got 6 problems. Okay, guys. So, okay, how long do we have? We're 35 minutes in. We still have like an hour and 25 minutes. So, looks like we got an hour and a half to finish these 6 problems. Let's do it. Match the functions and their derivatives. We have y equals cosine of tangent of x. Okay. I guess even though I can just look at these questions, I'll do it on paper to get more practice, I guess. Let's see. So, um, all right, we need the derivative of cosine. Listen, we got a product. Prime x. Oh no, this is sorry. This is not a multiplication. Oh no, I'm not using product. It's a combination of functions, so we're using the chain ruler. So we got equals. What is this? Tangent of x. Perfect. Okay, so we got tangent of x prime times what? Times cosine or times negative sine. Negative sine of tangent of x. Okay, and this is going to be, what are choices? Okay, here, all right, and the derivative of tangent of x is secant squared, I believe. Is there any secant squared in here? We got a secant. Ooh. Let's see. I mean, what I have is tangent of x prime times negative sine of tangent of x. Could this be it? Hold on. Hold on. Oh, what is the derivative of tangent of x? All right, I'm pretty sure it's going to be d. Whoops. What? D. Okay. Because, yeah, here we have the negative sine of x evaluated at tangent of x. And this over cosine squared of x. I mean, we know that secant is 1 over cosine. Oh, hold on. Wait. Derivative of secant. Of secant. Oh, no. I'm sorry. Tangent of x. Secant squared. Oh, interesting. So the derivative of tangent of x is secant squared. And secant is 1 over cosine of x. So secant squared of x equals to 1 over cosine squared of x. Oh, so if that's, yeah, okay, hold on. Let's see. Whoops, yeah, that'll make sense now. Hold on. So tangent of x prime is going to be secant squared of x, yeah, times negative sine of tangent of x. And this is the same thing as 1 over cosine squared of x times negative sine. Well, this is ugly. Hold on, dude. Let's. All right. Well, yeah. I think the answer is clear. This is going to be D, right? Yeah. That's what we got. Y equals cosine cubed. All right, that's fine. I don't think I'm going to do anything with that right now. Cosine cubed. Cosine cubed. The derivative of cosine cubed is going to be, okay, so if we use the chain rule, we get cosine of x. Hold on. No, what are we evaluating? The inner function. The inner function is cosine of x. So we have negative sine of x times uh times cosine, hold on, times negative sine of x cubed. Oh boy. Okay. Oh, no, 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 no. Hold on. No, we just treat the cosine like a variable. Oh, there you go. Okay. Yeah, so what's the inner function? The inner function is the derivative. Sorry. We want g prime of x, so the derivative of the inner function. And the derivative of the inner function is going to be negative sine of x. So we have negative sine of x times 3 cosine of x squared. Ah, let's go, dude. Yep, that's B. Perfect. What else we got? We need to evaluate the derivative of tangent of x. Oh, well, that's what? Secant squared of x. Um, or that can be the derivative of sine over cosine squared. And that's the same thing as cosine over negative sine squared. Yeah, I actually don't know how we're gonna get to secant, but it's fine. I mean, we already know. Um, tangent of x. I mean, this is literally just a function. I no need to apply any a differentiable rules, a differentiation rules. What do we get? Hmm. Tangent of x. Oh, dude, I'm hungry. I went swimming today and I haven't had breakfast yet. Let's see. So D and B are already taken. So we only have C and A. All right, I'll do number 4. We have sine of x times tangent of x. Perfect. The product rule. We do. What do we do? Sine of x times secant squared of x plus um, cosine of x times tangent of x. Oh no. Okay. Here, I'm just gonna write this down. Let's see. So we have y equals sine of x, tangent of x. This is equal. Okay, so y prime is gonna equal sine of x, secant squared of x plus cosine of x tangent of x. Okay, but I don't know how that matches. Okay, hold on. They did apply video. Derivative of secant of x. I believe that's important. What do we see here? How long is this? Okay, it's only 5 minutes. Here. Sorry. They made me breakfast. Very cool of them. Close the door. Perfect. Okay. How old are you? I am. Yeah, I don't know if I should share that. All right. How old are you? I am 15 years old. Just use AI. I could use AI. I'm not sure if I'd learn as much um, as I would without using AI. So probably for more time constrained situations. But yeah, It's a good idea. Hmm. That's right. Secant is by definition the reciprocal of cosine. Or the other way around? Okay. Sounds good. The derivative. Mhm. Okay. Mhm. Hmm. Chain rule, right? Yeah. Yeah, so we get negative sine of x times times negative cosine of x to the power of negative 2. Mhm. A negative 2. Negative sine of x times negative 1 times cosine of x to the power of negative 2. Yes. Yeah, negative positive. Oh, cool. Wait, what? Oh, yeah. 1 over cosine x to the power of 2. Even more? Oh, isn't that close to a tangent? Is a sine of x over cosine of x, yeah. Hmm. Times 1 over cosine. Mm. Hold on, and we're all evaluating the derivative. Mm. So sine of x over cosine of x is tangent of x, so we have so is the sorry, the derivative of secant of x equal to, um, tangent of x over cosine of x? I think secant yeah, 1 over cosine is secant, tangent. Oh, that's so cool. That makes total sense. Oh, that's actually really cool, guys. Awesome, dude. Yeah, wait, 40 wait, how long are we? 49 6 problems. Uh-oh. We, we gotta hurry up. All right, I'm just finish my breakfast. Okay. Mm. So, let's see. Uh, how do we do this? Y equals tangent of x. Let's see if we recognize anything here. Um, Sine of x times tangent of x. Huh. Dude, no. I don't know. I mean, I don't want to guess. However, I don't want to spend forever on this problem. Tangent of x, I mean, there's no rule to apply. And for question number 4, I try to do the product rule. However, I don't see. I mean, I see sine of x, secant squared of x. Huh. Yeah, I don't know. I have a feeling that this is C and this is A. I think I remember seeing 1 plus tangent squared. Okay, that's correct. Can I show like an explanation? Okay, how do they do this? Squared of x, sine of x, and that's equal to um -3 cosine. Okay, 3. Yeah, why would they do that? Oh, interesting. Okay. Um times tangent of x. Interesting. Okay. Y prime equals. Okay. Oh, hold on. I see. Okay, so we're just doing manipulations of what we know about trigonometric identities. Hmm. Hold on. Y equals cosine. Oh yeah. You apply to the chain rule. How about for a number 2? That's tangent of x. Okay, hold on. What did you do? All right, secant squared of x. Why is secant squared of x equal to 1 plus tangent squared of x? That's odd. I don't know if you guys see it, however. Okay. It's fine. Okay. Well, I'll make sure to remember that. The derivative of tangent of x is secant squared of x, and that is equal to 1 plus tangent squared. Okay. Okay. Yeah, you probably applied like a. Oh, is it like a power rule then? Secant times secant? No, no, no. Well, okay, I don't know. Well, okay, and then we have sine of x times tangent of x. We did the product rule. Uh, that's what I got, right? Sine of x. Where are we? We did cosine of x, tangent of x, sine of x, secant squared. Yep, that's what I got. Yep, cosine of x, sine of x over cosine of x, and that's just simplifies to sine of x. Then we have plus sine of x times 1 over cosine squared of x. Okay, I see. Yep, just manipulating what we can. Okay. Sine of x. All right, we just play around over here. I see. Sine of x, 1 over cosine squared of x. Okay, we have sine of x plus. Oh, hold on. 1 over cosine squared of x. That's secant squared of x. Oh, no, 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 no. I see what he did. Sine of x over cosine squared of x. That's tangent of x times 1 over cosine of x, and 1 over cosine of x is secant squared of x. So we get tangent of x times secant of x. Yep, I see it. Okay, and then we have 1 plus, oh, hold on. Then we have cosine of tangent of x. Cosine of tangent of x. Cosine of tangent of x. What do we do there? So we did negative a sine of x of derivative of tangent of x. Okay, first of all, what rule do we apply here? Chain rule? Cosine, yeah, a chain rule, I think it looks like. Okay, so we do the derivative. Okay, they're doing derivative. Okay, whatever. So derivative of the inner function is secant squared of x. Yeah, so we see it right there. And then we do times derivative of the outer evaluated at the inner function. So that is going to be negative sine of x of tangent of x. And then, yeah, so we have negative sine of x of tangent of x times secant squared. Okay, I believe it would be cool if we could do this one again, but with different problems, but looks like we got to move on. Okay. Oh, look, and here we got a video. It's 8 minutes. Can we do this alone? Okay, I think we can do this alone. Let's do it. So we have f of x equals negative 7x squared minus 6, all of that to the power of 3, times 6x squared plus 2, all of that to the power of 15. Yep, well, we're for sure not going to be doing the algebra to get that number. Let's see. Well, I mean, we obviously got the power rule, and I see that we also got a composition of functions. So let's do that. Yeah, so y equals 7x squared minus 6x, all of that to the power of 3. Y prime is going to be the derivative of the inner function. That's going to be negative 14x. I think that's it. Times the derivative of the outer function evaluated at the inner function. So it's going to be 3 times negative 7x squared minus 6 to the power of 2. I see. Okay. And now we multiply that. So we get, all right, yeah, negative 14x times, okay, what is negative 7x squared minus 6, all of that to the power of 2. We get, so negative 7x squared times negative 7x squared is going to be, so negative 7 times negative 7 is going to be 49. 49x to the power of 4 plus 7 times 6 is what? What is 7 times 42? 42x squared plus 42x squared plus 36. That's what we get. Okay, that's quite long. And if you multiply that by 3, what's 49 times 3? We get like 147, I think. 147x to the power of 4 plus, and 42 times 3 is 126. 126x to the power of 2. Oh, so plus another 126. So 126 times 2 is going to be 252. 26, yeah. Then plus 36. And then we got to multiply all of that by 14, which, yeah, I don't think I'm going to do that, but it's fine. We got that. And then we have 6x squared plus 2, all of that to the power of 15. So that's another chain rule function. So if y equals, all right, so this is y1, this y2. y2 equals 6x to the power of 2 plus 2, all of that to the power of 15. y2 prime is going to be, it's going to be 6, 12x times 15, 6x squared plus 2 to the power of 14. There we go. Yep, well, I'm not going to simplify that. Oh, and now we got to do the product rule. So, okay, I'll just type it in here. So we have, ladies and gentlemen, we have f of x. So we have negative 7x to the power of 2 minus 6 to the power of 3 times g prime of x. So that's going to be, let's see, 12. We don't have a negative, so 12x times. Okay, we can simplify that. So what's 12 times 15? That's, let's see, 20 to 40, 180? 180? Oh, that's right, right? Yeah, 12 times 15, 180. 180x, um, 6x to the power of 2 plus 2, and all of that to the power of 4. Um, can you do that? Yeah, you can do that, obviously. All right, and then plus f prime of x. So then here we're going to have negative 14x. Okay, better put some parentheses. Negative 14x. And then a huge number right here, which is going to be 147x to the power of 4 plus 252x to the power of 2 plus 36. Why is it doing that? Yes. That's f prime. Whoops. Oh, and we're not done. Hold on. Yes. No, times the outer function. Not outer function. Just g of x. G of x is 6x to the power of 2 plus 2. All of that to the power of 15. I mean, I think I got this right. This is... Oh, okay. What happened, dude? Yeah, so assuming that I got all of this right, we have f prime of x equals, so the first function, yeah, to the power of 3. Oh, phew, I thought I did not put that. And then we got the derivative of the second function, and that's going to be this huge number. How did I get that, actually? Oh, yeah, I squared everything. Okay, it's fine. I won't square things right now. Dude, wait. How did I get 180x? Okay, I'll just... $12x times 15. Oh, that's why. 14. And if that's still wrong, okay, cool. All right, well, perfect. We found one error. Now we have plus, and then we have the derivative of the first function, and that's going to be negative 14x times to the power of 4 to the power of 2, and then nothing. And then we have times g of x to the power of 15. What did we get wrong? Okay, so I'm just going to express this in what we had before. We have negative 14x and negative 48, 14, 28, 42. Oh, phew, bro. Times negative 7x squared minus 6 to the power of 2. All right. Oh, okay. So looks like not simplifying worked. What do we have here? Okay, yeah. We got that. Okay. Let's do the next item. All right, we have this. We have f of x equals negative 5x. Oh, hold on. Here, in fact, let's just put f of x in the middle. equals negative 5x square root over square root of 7 minus 5x. Cool. Okay. So we have a quotient rule, but then we have the chain rule. Okay. So let's just say that y equals the square root of 7 minus 5x. So to evaluate that, we do, a y prime, that equals negative 5 times 1/2 times 7 minus 5x, all of that to the power of, negative 1 over 2. That's what we have. Can we simplify? No, I don't think we can simplify. Well, unless we could do a negative 5 times negative 5 over 2 times 7 minus 5x to the power of negative 1/2. Cool. Okay, and now we can do the quotient rule. So f prime of x is going to equal, okay, here we go. So we got f prime of x. So the derivative of negative 5x is simply negative 5 times just g of x. So that's going to be the square root of 7 minus 5x. 7 looks weird. Let's fix that. And then minus, we do f of x, just a normal. So minus negative 5x, that turns into a plus, times g prime of x. So that's going to be negative 5/2 times 7 minus 5x raised to the negative 1/2 power. Cool. So, well, dude, all these negatives are freaking me out. All right, so we have negative 5 times square root of 7 minus 5x. And then we have plus, oh, hold on, wait. Oh, darn it, dude. All right, well, okay, minus 5x. So minus negative 5x is simply plus 5x, but then the negative 5/2 is going to make it negative. So negative 5x 5/2 times 7 minus 5x raised to the 1/2 power. And simplifying even more, we get negative 5 square root of 7 minus 5x. We can do, what is that? Negative 25 over 2x times 7 minus 5x to the power of negative 1/2. All right, cool. Well, I think, oh, hold on. Oh, no, dude. Okay, yeah. We forgot the denominator part. And this is divided by g of x to the power of 2. So simply 7 minus 5x. Literally, that's it. Can you simplify with that? I don't think so. All right. Here we go. So we have negative 5 square root 7 minus 5x minus 25 over 2 x times, hold on, where is it? 7 minus 5x. This is to the power of negative 1/2. And all of this is divided by 7 minus 5x. Perfect. Let's go, dude. All right, we're 50% of the way there. Let's go. Do you know the quotient rule? Yes. I think it's the derivative of 5x times g of x minus f of x times the derivative of g of x all over g of x squared. I think that's it. Did I get it right? And aren't you too young for calculus? I don't think so. I mean, there are probably some kids my age who are also doing calculus in school. Um, yeah. Um, let's see. Are you doing calculus as well? Um, are you also like in high school or something? Because it's kind of cool. You know, we should like do like a live stream where whoever solves the calculus problem the fastest wins. Just kidding. What am I saying? Oh, I'm just yapping over here. It's fine, guys, right? We can yap in here, right? Yeah. Yapping is allowed in this live stream right here. Just okay. Let's do this. We're not done though. We're 1 hour and 11 minutes. We've got 49 minutes left. But it's fine. That's plenty of time to finish 3 problems. So let's do this. Yeah, let's not get distracted. We need to lock in. In fact, where's like our lock in? Yeah. In fact, yeah, we don't need like a lock in hat or something. Whatever. Let's do this. So we have y equals cosine of. Oh, whoa! I'm sorry. I completely missed that. Y equals 3 plus cosine squared of x. All of this raised to 8. And dy dx. I think I always find this notation a little more confusing. The way I see it is apply the derivative to y in terms of x. I think that's how you see it. Hold on. What is it called? Leibniz notation? Yeah, I really don't know how to. Notation. Notation. Okay. Increments of x and y. Okay. Yep. Consider y as a function of a variable x or y equals f of x. What's up, bro? He's kind of cool, isn't he? Yeah, this guy was like a polymath. I did a bunch of things. History of mathematics, history of philosophy, theology, ethics, politics, law, history, philosophy, games and music, biology, probability theory, medicine, geology, psychology, linguistics, and computer science. This guy's the definition of a polymath. This guy's insane. Incredible, bro. In the binary modern system. Yup. He's crazy. Of course, in a good way. I mean, okay, hold on. There you go. Notation for differentiation. Suppose a dependent variable y. Oh, this is giving a chemistry vibes. Hold on, where was I? Okay, the derivative of y with respect to x. Okay, I think that's how we should see it. So, the derivative of y in respect to x. Okay. All right, let's do it. I'm not exactly sure what that means, but I think I have somewhat of an understanding. Well, okay, let's do this. So first, we see like a chain rule. Oh, in fact, we see 2 chain rules. We have something to the power of 8. That's the outer function, y to the power of 8, a to the power of 8, and then we have something in the inner function. But then we also have a cosine that squares. So we have 2 chances for the chain rule. So first, I believe we should begin by evaluating the derivative of cosine of x. So, all right, let's say that a equals cosine squared of x. So therefore, a prime is going to be, what? Hold on, I need more. Let's see. So the inner function is cosine of x. So we have the derivative of the inner function, the derivative of cosine of x, that's negative sine of x times, and then we have y squared or something. All right, probably a bad use of variables, but it's fine. So we have 2 times cosine of x. Oh, just that. Okay. So in the end, oh, interesting. So we have 2 cosine. Okay, I'm sorry. We have negative. So We have negative 2 sine of x cosine of x. What's that identity? 2 sine of x cosine of x identity. That equals to sine of 2x. Okay, so hopefully we can utilize that later, but it's fine. Perfect. All right, we got that. Oh, wait, hold on. So we'll get negative sine of 2x. Yeah, I'll just put that right there. I don't know if that's necessary. Probably not. Just in case, though, since we're using that a lot. And then we have the derivative of the entire function. So we can also utilize the chain rule right there. So y prime will equal the derivative of the inner function, and that's going to be the derivative of 3 plus cosine squared of x. The 3 is 0, so it doesn't matter. And then simply we do derivative of cosine squared of x, and we already know that, which is negative sine of 2x, negative sine of 2x, much shorter than what we had, so I'll just use that there, times the derivative of the outer function evaluated at the derivative of the inner function. So we get 8 times 3 plus cosine squared of y to the power of 7. All right, there you go. That's what we get. So negative sine of 2x times, okay, yeah, I know times 8. In fact, I'll just put the 8 here. 3 plus cosine squared of y to the power of 7. All right, so I guess we'll just have to put the other derivative we had. Yeah, so we don't have negative sine of 2x. We have negative 2 sine of x cosine of x. Yeah, that's what we have. Hold on. Yeah, I think I did this right. In fact, I'll have to, if I do not get this right, I'll have to check my math. Yeah, okay. What did we get wrong? Let's see. So, the derivative of cosine squared of x is negative sine of x times 2 cosine of x to the power of 1. So, and then we have, so that's negative 2 cosine of x, sine of x. And the same thing as sine of x, cosine of x was wrong. Yeah, no, I thought that looks pretty good. And the other thing we have is going to be the derivative of the entire function. So it's going to be negative. Oh, that's the thing. Hold on. Oh, wait. Oh, no. Hold on. We need to know the derivative. Oh, no. That's good. What's the derivative of the inner function? Yeah, hold on. That's what we just evaluated. Negative 2 sine of x cosine of x. All right, so we have 2, and we have 8. 2. Okay, I'll just put these here. Why do we have a y here? Oh, was that the root of our problem? Oh, come on, bro. Why did we have a y? Darn it. Could we have also utilized a secant as well? Oh, he had a tangent of x, so I see. Okay, perfect. We got 2 more problems. Guys, we're cooking. Let's go. Chains, step it up. This is weird. Why do you do the inner chain rule before the outer? Interesting. Okay. Yeah, I guess you're right. I guess I could do f prime of f prime of whatever before g prime of x. I don't know. I guess I just remember it that way, but it's just one way to do it. You put y instead of x. Oh, thank you. I should have looked at the comments. I see. Thank you very much, dude. Are you even Asian? Come on, you can do this. Am I Asian? No, I don't think so. I'm not even sure if I'm math Asian. I don't think I'm that good. Unbelievable. I know, but I finally got it right. So let's go. Thanks for your help, guys. Thank you. We got two problems left, and we're 1 hour and 20 minutes. We got like less than 40 minutes, but we're almost done. Let's go. All right, we got here. Let f of x. So we have f of x equals 3x squared cosine of 5x. Okay, gotcha. So we need to evaluate f prime of x, then f prime of 1. Ooh, the double derivative of x, and then the double a derivative of 1. Interesting. All right. Yeah, I don't think it should be too hard. I think I've done this before. You just apply the derivative to the derivative. Okay, let's do this. So first, let's begin with the single derivative, the first derivative. I see like a product and I see cosine. So, okay, I guess I'll try to evaluate the derivative of cosine of 5x first. So y prime is going to equal, okay, so doing the outer function first, we do negative sine of 5x evaluated at the inner function times the derivative of the inner function, which is simply 5. So in the end, we simply get negative 5 sine of 5x. Perfect. Okay. And then we need to do the product rule, I think. So f of x, no, sorry, f prime of x equals, so we have 3x squared times the derivative of g of x, which is cosine of 5x. So here we get times negative 5 sine of 5x times, plus, and that's going to be, here, I'll put plus down here. I'm going to run out of space. Plus what? Plus f prime of x. So that's the derivative of 3x squared, and that's going to be 6x, and then times g of x. So that's simply cosine of 5x, right? Perfect. Okay. So can we simplify? Yeah. Okay. Let's try simplifying. We get negative 15x squared sine of 5x plus 6x cosine of 5x. Okay, I don't think we can simplify anymore, but that's pretty good. So we'll just plug that in. Negative 15x squared sine of 5x plus 6x cosine of 5x. I typed that right? Yeah. All right, now evaluate it at 1. We get negative 15 sine of 5 plus 6 cosine of 5. All right, hold on. Let me. Okay, I feel like I'm just plugging in numbers right here. I'm not understanding this intuitively. Hold on. So I'm finding the derivative. So we have like a function, a curve, right? And then we want to find the slope of the tangent line at x equals 1. So yeah, this is the literal slope. The derivative is a slope. That's the slope of the tangent line, tangent to the curve at x equals 1. Yeah. All right. We got it. We're cooking. All right. Now the double derivative. My goodness. So, we're gonna have to do the product rule. Oh my goodness, dude, that's insane. Oh my goodness, bro. Okay, guys, I don't know if you see it, but this next step is gonna be tough. It's gonna be a lot of algebra, but we got this. Okay. Okay. I think what we're gonna have to do is do the chain rule for sine of 5x, the chain rule for cosine of 5x, the product rule for negative 15x squared times sine of 5x, and then the product rule for 6x cosine of 5x. So we're gonna have to do four differentiation rules. Whew. Okay, let's do this. We literally have 2 problems left, and we got this. Keep one difference, other plus other, way around it. What do you mean? Keep one like a derivative, a different, the other way around. So they put this first. Here. All right. Let me just continue. Okay. So we have, gosh, dude, we have, um, okay. I was gonna. In fact, should I? We have f of x equals negative, whoops, negative 15x. Negative 15x squared sine of 5x. Okay, hold on. Wait, if I press submit answer, I'll get, okay, perfect, cool. Just making sure that I had the correct answers. All right, negative 15x. Okay, sorry. There we go. Let's put it here. We could factor sine of 5x. Oh, I thought it might not be a bad idea. Okay, I'll do that later. All right, so we have that. So doing, that's tough. Here, I'm just gonna open the entire a new page. So yeah. Oh, whoops, a 6x. Okay. Okay, so let's do the derivative of sine of x, and then wait, oh my goodness, no, sorry, we have cosine of 5x. That's important. Yeah, okay, no, we can't factor. We can't factor. Okay, so if y equals sine of 5x, the derivative of that will be, all right, will be, what's a derivative of outer function? That's going to be cosine of 5x times 5. All right, 5, yeah, and we get 5 cosine of 5x. Perfect. And then if y equals cosine of 5x, y prime, dude, will be negative sine of 5x times 5, and that's simply equal to negative 5 sine of 5x. Easy, right? Yeah. I hope I didn't get anything wrong there. Yeah, just making sure I didn't get anything wrong. Derivative outer function, times the inner function, a derivative of inner function. Perfect. Okay, I think we're good. Now we're gonna do the product rule of these two terms right here. Yeah, product rule of this and of that. And then we simply add them together, and we got our answer here. Then we plug in 1, and that's gonna be our answer. So now we do. So we have. So the let's do y equals negative 15x squared sine of 5x. So y prime is going to equal, what's y prime going to equal to? It's going to equal to, so it's going to equal to negative 15x squared times, what's g of x? Okay, so we're doing sine of 5x. So we're going to do, so this is our derivative right here. 5 cosine of 5x. That's what we're doing. So 5 cosine of 5x plus, and then the derivative of f of x, and that's going to equal what? Negative 30x, and then times, we're going to do g of x. And g of x is simply sine of 5x. Perfect. Perfect. Awesome. All right. Now we simply finish simplifying. Wait, that's 5 cosine of 5x. Let's make that clear. 5x. Yeah, there we go. A little unclear. So negative 15 times 5 is going to be 75. Negative 75x squared cosine of 5x plus or minus a minus 30x sine of 5x. Perfect. And now, whoops, 5x, not 5. And finally, doing the product rule for 6x cosine of 5x. Yes, so if y equals 6x cosine of 5x, 5x, not 5. What are we doing here? Perfect. We do y prime equals, so we do 6x times the derivative of cosine of 5x, which we said that was negative 5 sine of 5x, plus we do the derivative of 6x, which is simply 6, times g of x, and that's simply going to be cosine of 5x. Perfect. We simplify what we can. Okay, that's, oh, yeah, 5, dude, come on. So 6 times 5 is 30. 30x, whoops, negative 30x sine of 5x plus 6 cosine of 5x. And adding that together, we get negative 75 x squared cosine of 5x minus 30x sine of 5x minus 30x sine of 5x plus 6 cosine of 5x, right? Yeah, why did I put a 5? This is supposed to be 5x, right? Yeah, I hope. Perfect. And here looks like this simply simplifies to this, since this is the same. Plus 6, so we get here, what, like 69. Perfect. Now we simply plug in 1, and we get negative 69 cosine of 5 minus 60 sine of 5. All right, guys. Crap. Okay. We got that right, but we got this wrong. Wait, what? Interesting. Okay, hold on. So, let me just we got that right. So I think, okay, I'm just going to write out the expanded version. X squared cosine of 5x minus 30x sine of 5x minus 30x sine of 5x plus 6 cosine of 5x sine. Perfect. Okay. Yeah, I don't know why we got this wrong. Negative 30 minus 30 is negative 60. Okay. Last question left. Oh, what's this? Y equals u times v, where functions of x. Park rule. Keep one inner function, the difference. Keep one inner function, the differentiable the other way around. Right. Yeah. Y prime equals u prime v plus v prime u. How do you feel about integration? Let's see. So, I'm not an integration yet in ASU. However, I do a calculus in AOPS, Art of Problem Solving, which is like a competitive a math website. So I'm seeing like the chain rule in integration, substitution in integration. I think I have I have like the integration concept well. However, I still think I need a much more practice. How about you? Do you know integration pretty well? Yeah, integration, I find it much tougher. Yeah, it's kind of like the opposite of a differentiation, though. So it kind of builds off of what we're learning now. Okay. All right, hold on. So we got 25 minutes left. Come on. We gotta finish this last problem. Let's do this. Go on. Was there a video for question 5? Yeah, no, there wasn't. Let's do this, guys. Okay. Suppose that f of x equals 6x over 3 minus 2x to the power of 4. Cool. Find an equation for the tangent line to the graph of f at x equals 1. All right, yeah. So the only thing that we need to do is simply find the derivative, plug in 1, and then and that would be our slope for that point. So we do like y minus y1. Oh, interesting. They don't give us the point. Oh, it's fine. Yeah, so we're going to use point slope form. Y equals y1 equals m, which is the slope, times x minus x1. So we have yeah, x minus x1 is x minus 1 because they're giving us the 1. We plug in 1 in f of x, yeah, just raw f of x, and that'll be our y1. So y minus what we get from plugging in 1 in f of x equals m, the derivative we get, times y minus, x minus 1. Yeah, I think they do it here, but we can do it alone since we're also pretty good. We're proficient in math. I'm just gonna line over here. Okay, let's do this. So we have f of x equals 6x over 3 minus 2x, all of that to the power of 4. This equals, so we have the bottom, the denominator, which is going to be, we're going to use the chain rule, and then we have an entire quotient. So we're going to use the quotient rule. So if y equals 3 minus 2x to the power of 4, y prime is going to be the derivative of the outer function evaluated at the inner. So we get 4 times 3 minus 2x to the power of 3. We just treat the inside as a single number, times the derivative of the inner function, which is going to be negative 2. So in the end, we get negative 8 times 3 minus 2x to the, all of that to the power of 3. Perfect. And then we must do the quotient rule for the entire function. So we have f prime of x equals, so we do f prime of x, or the derivative of the numerator. So that's 6. 6 times 3 minus 2x to the power of 4 minus 6x, what was going on out there, times the derivative of the denominator. So negative 8 times 3 minus 2x, all of that to the power of 3. And all of that is going to be over the denominator squared, which is going to be simply 3 minus 2x to the power of 8, I think. Yeah. 4 times 2 is 8. Perfect. All right, cool. Now let's simply simplify as fast as we can. Speed mode. We do, what do we do? Wait, whoa, that's weird. Hold on. Sorry, I just got to put a parentheses right there. Why did we get, hold on. Where did that minus 6x? No. Sorry, you don't put minus 6x. No, okay, sorry. We're good, we're good. So we do 6 times 3 minus 2x to the power of 4 minus, so, or plus, because we have minus and minus. So 6 times 8 is 48. So 48x times 3 minus 2x to the power of 3. And all of this is going to be over 3 minus 2x to the power of 8. Perfect. Yeah, I don't think we can simplify anymore. Oh, okay. And then we must do, so the point slope form, yeah, y minus y1 equals m times x minus x1. So y therefore equals mx minus sorry, I just m times x minus x1 plus y1. There we go. So plugging that in, yeah, we get y minus m. So we'll just plug in our entire slope, 3 minus 2x to the power of 4 plus 48x. Yeah, I'm just gonna make that 8 look nicer. 48x times 3 minus 2x to the power of, 3. All of that is going to be over 3 minus 2x to the power of 8. And that's our slope. And then we do, x minus 1, because x equals 1, so x minus x1, and then plus y1. So we plug in 1, we get, and f of x, we get 6 over 3 minus, hold on, I'm just going to put parentheses, 3 minus 2, all of that to the power of 4. All right, I think that's good. No, that's not good. What happened here? We plug in 1, we get 6 over 3 minus 2. Oh, wait, hold on. So just 1. Wait. 2x. 2x, yeah, that's 2, right? All right, 1, or we get plus 6. Yeah, wait, for this correct. All right, I think this should be good. No. All right, how long do we have? We have 19 minutes left. Oh, come on, we got this. Oh, what's going on? Yeah, this is. Let's see. Okay, all right, I'll begin from the beginning. So the derivative of here. Okay, here. Sorry, I'm just gonna open the door. So I think I figured out my mistake, or I was told on my mistake. Yeah, we need to plug in 1 to x because we're evaluating the slope of the tangent line at x equals 1. So yeah, but my bad. So that's 1, 1, 1, 1. This is 1 to the power of 8, or simply 1, so we can just get rid of that fraction. This is 1 to the power of 3, so we can just get rid of that. This is 1 as well, so we can get rid of that. Minus 48. 40 plus 6. Wait, what? How did we get 6? Oh, that's, yeah, okay. So 6 plus 6 is 12. Negative 48 plus 12 is negative 36. Yep, that's what you get. That's our tangent line. And that's wrong? Oh, dude, okay. What happened? Can no, we can't. All right. So we have 6 minus, 6 times 3 minus 2x to the power of 4, right? We just replace a 48, 3 minus 2x, or 2 to the power of 3. Then we have 3 minus 2 to the power of 8. X minus 1. And then plus y1. All right. So we get 6 over 3 minus 2 to the power of 4. All right, so all we got to do, simply replace x with 1. Oh, we just did that. So just do algebra. 1, 1, 1, 1. 1 to the power of 4 is 1. So 6 times 1 is 1. 1 to the power of 3 is 1. So 48 times 1 is 1. 8 to the power of 1 is 1. So that's simply 1. 6 over 1. So we can get rid of that. We can get rid of that. We have, so 6 plus 6, no, hold on. Then we have 48x minus 48. But hold on, bro. What's going on out there, dude? Oh, wait, hold on. Hold on, dude. Okay, dude, what is this? So we have that. Okay, so we got that right. So we then have x minus 1 plus y1, 6. 2, 1. 3 minus 2 is 1, right? 3 minus 2, 1, right. So, hold on. Tangent to the graph. Yeah, we literally replaced 1, dude. What's going on? Hold on. What did he do here? Sub-zero. Sub-zero? Okay. Yeah, so replace 1. 2 times 1 is 1. 1, 1. We don't replace that, right? No. Do we? No. I mean, I actually just replaced 1. Yeah, yeah, okay. Dude, did we do like our algebra wrong or something? Let's see. 3 minus 2x. Okay. So we have 4 times that times negative 2. Right. Negative 8. Oh, beautiful. Okay. And then we apply the quotient rule. 6 times derivative of the. Oh, okay. Hold on. Oh, no. My bad. 6 minus 6x times that derivative. Over. Oh, I see. Oh, wait, no. No. Oh, that's good. We have to the power of 8. I mean, that looks good. 6x negative 6x and then negative 8 is plus 48. 6 times 8. That's 48, right? 6 times 8, 48. 3 minus 2x to the power of 3. Dude, what is going on? Okay, hold on. So this is 1. This is 1. This is 1. 1 to the power of 8 is 1, right? 1 times 1 is 1. 1. Let's take that off. Oh, hold on. Wait, so that's 54? 54. Is that what we got wrong? Okay, I see. Minus 54. Negative 48. All right, that should be it. We're a genius. Let's go. Let's go. We're a genius. First try, guys. And we were 10 minutes early and we completed our entire homework. Let's go. We're so good. And now we got a quiz. We should also live stream that, but who knows about like the copyright and stuff, you know? What's the capital of China? It's like Beijing, I think, right? Capital of China. Let's go. Yeah, Beijing. Bro, come on, it's not that hard. I know. It's not that hard. Got stuck on a very small issue. You're completely correct, bro. Well, guys, thank you for tuning in. Thank you for watching me do my homework. It was a lot of fun. Knowing that you guys are like helping me, really supports me in doing my homework. So thank you for joining. It was a lot of fun. I'll see you guys next time, hopefully for that quiz. Okay, I see you all.